be the center point, and these loads are shown above the beam over here, which is moving from left to right, from support A to support B, having the concentrated loads of 120, 180, that is 200, 80 and 80, and these concentrated loads are having the center to center spacing of 32 and 32 meters consecutively. So this is a question paper question. This question has arisen in the question paper, VT question paper final year with the 20 marks. So if your model is comprising with 16 marks, then it will be asked for 16 marks, because it carries the heavy weightage of marks in the section of in the either of the section of each module. So for example, it is in the question model number 2. In model number 2, you'll be getting 2 questions including R. In the R question, you'll be getting only one question with this concept. We need to solve one question. It is more than enough to get the particular marks allotted for that. And this is the question per question that I would like to discuss over here. That the shear force and bending moment, when they said to calculate, it is all about to know what are the influence line diagrams for those concepts. Those concepts in the sense, and the shear force and bending moment. So here I considered the shear force diagram. First thing, they say to calculate shear force, that which is positive, again which is negative. Apart from that, the positive and negative shear force, we need to have the load combination on right side of the span and the left side of the span. And keeping that in the mind, we look forward for calculating the shear forces. So it is written here, the influence line diagram for shear force is shown here with the diagram, which is considered for positive shear force, because the loads which are written or which are considered on the right side of the span or right side of the section, that is leading to give the positive values. So now it is again a second thing. It is again a concept of taking the coefficient values for each section of the loads, where they are exactly lying. Right. At this point, total will be having 24, right? 24 is the total length of the beam. So on that 24, there is a section we need to consider for 12 meter. That I will try to show this in this concept. Show here. This is a total span. In the total span of 24 meter. In the total span of 24 meter, here I would like to consider the sections for each of the loads. So how do you consider? So these points need to be known. So how do you get these points? And these points are considered for whole span, right? These points are considered for whole span. That means we need to have for 12 meter for the span of 24. So 12 by 24, that will be a 0.5. On either side we have a 12 meter span. On either side we have a 12 meter span, then 0.5 and 0.5 will be there. And the 0.5, because if you consider on this right span, always the right span when it is considered, that is written at the top, and the left span it is considered, the values will be written at the bottom as a negative shear forces, negative values, coefficient values. And on either side it is 12. On either side it is 12, so no need to calculate it again. The 0.5 will be the value. So 12 is the span for 24, that is written, it is here. So now 0.5 is the triangle that need to be considered over here to compare or to have an similar triangles. So if you consider 0.5 and it is a 12, right? So 0.5 by 12, that is one of the triangle that I could write here, that is to get the coefficient values. 0.5 divided by 12. Again, which is equating to any one of the triangle if you consider. So I will consider this triangle and to get the coefficient value for this one, for 80 kilonewton load. So how do you write that? And this value is unknown. Say I will write it for x. Then what would be the distance of here? So total it is 10 and 12 it is. In this 12, the 2 meter is left here and remaining is 10 meter. Right? So with this, so if we calculate, what would be the answer here? We'll show it once again here by referring to the equations, by referring to the similar triangles over here. Here it is a 0.5. Sorry. Here it is a 0.5 and the coefficient value is obtained, and this 0.5 is for 12 meter, and that is the value at the section, and at this section we need to consider for the value of that is coefficient value of the 80 kilonewton of intensity of load. So how do you calculate here? The same thing, the similar triangles need to be considered, and again here it is a similar triangle one more, and again it is the similar triangle one more thing. Right. So once you consider these things, and apart from this we have another one, that is at this point, which is first I will let you see, let you show what are the values that are, what are the triangles that are considered for the intensity of loads. Right here in this, right. So this much is more than enough to have the values. So this is the span of 12 meter. For 12 meter we have got 0.5, and again we have an 10, that is remaining 10 meters span over here. For this, with the blue line, I would like to write it here. For 12 by, that is 24, we have 0.5, and for this, how much it is? 10. So the total span of 10, for the total span of 10, for the total span of 12, we need to get for 10 meter distance. So total span is 12 here. For 10, it will be 0.83. 0.83. And with the color code, I would like to write here for this triangle. For this triangle, so what would be the value over here? For 3 and 2, total it is 10 meter, and here it is remain 2 meter. 2 plus 2, 4 plus 3, 7. That is for 7 meter. We need to consider the section for the total span of 12 meter. So what would it be? 7 by 12, it is 0.58, and the corresponding values are written in the section, at the section of the span. So now what is the section for this? Here it is total of 5 meter. 5 meter for the span of 12. 5 meter for the span of 12. So 5 by 12. 5 by 12 will be the 0.41. And again it is written is for 2 meter, which is written for this value, that is 2 meter, which is remaining on the side. So 2 by 12 it is. So 2 by 12 will be 0.16. So that means we need to have the distance from the end. So if you consider the end of the section over here, if you consider the end of the section from support to the section where you are pointing out, so this is the support condition. If you want to consider for this section, and you need to have this one, and again if you want to consider this section, you need to consider the support from this one, not only the particular support, right? So that is how we need to have the different distances for each section that should be measured from the supports, total support, right? So this is the total that is coefficient values that we have to multiply, and after that just multiplying the coefficient, that is intensity of load, with the coefficient values to get the value that is for shear force. And one more thing, whenever the particular loads are moving from one side to side, that need to be considered. So with this, it is written over here. For 80, we have 0.5. For 80 into 0.5, that is considered as a positive. On the right side, whenever you are calculating the shear force on the right side of the section, you need to consider the positive value. And if you consider the negative side or the left hand side of the section, we need to consider for minus sign. So then next 80 into 0.83, and next 200 into 0.58 plus 180, which is all taken positive, is because these are lying with the positive sign, which is above the beam or above the section. These are the sign conventions we had discussed. And 180 into 0.41, and then 120 into 0.16, right? So these are all the values that are all considered for the center section, because these loads are moving. So what we had discussed in the previous problems, that is the loads for statics. So the load which is static at the position, which is not moving or which is not in the dynamic condition, that means which is not having any movement. So in that case, we have considered for that specific point only, like a beam where it is exactly considered the section. But in this case, it is acting and moving. That means that we can have all these loads on either positions. So for example, if this particular load is moving, and at this point we can expect this 180 kilonewton load, and at this point we can expect this 200 kilonewton load, like that. That means it is moving. So in this case, we need to consider, or we need to have the moment for this, the moment that is coefficient values for the section to multiply to the all intensity of loads. That is what we have already done in the previous problem. But what we have considered in the shear force, that in the previous problem they have not given any section to calculate, since we have not multiplied the coefficient value for the shear force. But in this question, they have said that to calculate for the particular point. So in that case, we need to have the coefficient value for multiplication. And now, right, so this is all about the coefficient, that is the shear force, and the positive movement, positive value, and that is obtained as 177.7 kilonewtons. And at the same time, if you want to calculate the negative shear force, these loads are placed on the left side of the section, and that as shown in the figure, and that is 120 kilonewton leading load, which is on the top of the section. 120 kilonewton leading load on the top of the section. So same thing, again we need to consider over here. For a span of 12 meter, we have a 0.5 coefficient value. And again at the each section, we need to consider the coefficient values for like this. So this one triangle that is made, that means why I am showing color distances. Color means to have the distance to measure from point to the support, or point to the end of the section. And apart from this, we have another section of load over here, which is considered in this manner. And apart from this, next that is another load which is moving. Like this, you can have it. And then we have another load which is like this. So that means each here, if you in the total span it is 12 and it is up to 10, it will be remained with 2 meter over here, and at this position it is 2 meter as it is already written, and for this span it is 3 meter, and for this span it is 2 meter, and for this span it is 3 meter. But we need to consider on the total length. So at this point, see, for the section 180 kilonewton load, if you want to know that, so total is the 12 meter, total distance is 12 meter from here to here it is. So in that 12 meter, if you consider for the section of 180, how much distance is remained, that is 3 meter. So 12 minus 3 will be 9. So 9 by the total length, 9 by total length of the span. And again from here if you measure 2 plus 2 4 plus 3 7 plus 2 9, here it is 9. Again if you consider for here 9 minus 2 will be 7, 7 by 12 it is. And again if you consider here 7 minus, that is 7 minus 3 will be 4, 4 by 12, and here it is 2 by 12. So this is how we need to have the value of the coefficients. Then later we need to multiply these coefficient values to the intensity of flow. So again it is considered same. So 120 into minus 0.5 here, minus 0.5 which is considered on the left side of the section for negative shear force. And next, so here it is a sign convention is shown, but it is we know that we have already said that it is the negative shear force we are calculating. So how much the value will be obtained, that is written. Whether it is any other section if you place, only thing is it is maximum shear force. The negative shear force and positive shear force is considered only because the load position is denoted with that sign value. But but at the time of considerations, it is to be shown with the values only, positive sign, complete value only. It is not say that negative or positive, because the shear force value is to be said, but whether it is negative or positive, the impact of the shear will be the same on the section. And that is the case. And then 120 into 0.5, and the remaining things are multiplied with the coefficient values 180 into 0.75, and again these things, and at the end of the calculation we have got the 205.1 kilonewtons. So this in these two, if you observe these two values, what they have asked in the question, it is to calculate maximum positive and negative shear force. So after this we can conclude that the maximum positive or negative shear force of the corresponding values are 177 and 205.1 kilonewton. That has to be written at the end of the calculation of shear force. And the same thing what we had discussed for the previous problems, it is the same thing, but only thing is we have calculated for the section. I hope it is clear for you. And let us move for the that is design, that is bending moment values. So absolute bending moment in the span. Again, it is similar that we need to have an CG, that is center of gravity of the load, because since the load is moving with different intensities of load and with the different center to center distances. In that case, we need to have the CG from the end, and later we need to have particular distances, particular distance values, which is eccentric from the actual load. So what we have done in the previous column is taking the moment about the leading load. The same thing is considered. 180 into 3, 200 into 2 plus 3 is 5, and 80 into 5 plus 3 is 8, and next last 80 into 10, and I'm dividing with all loads 180. So 120, 180, 200 plus 80 plus 18, which is sum of the all loads. So once you do that, the 4.515 meter is the total CG of the load. which is considered from here. So 4.5 means which is lying at the here. 4.51 which is lying at the here. So that we could consider 4.515 which is crossing the center distance. Then it is nearer to the load of 200 kilonewton, which is the maximum load since this distance that if you consider that is near to 200 kilonewton, hence the maximum moment is likely to occur with this load. So if the load is having the distance from support to here, it is about this one. So it is 5.4, sorry, 4 point, which is 4.515. Right, this is the total distance from the support, and if you consider the total distance to the load is 5 meter. To the load is 5 meter. So in this 5 meter, how much it is having an eccentric to the load? Since we are getting the distance of CG at this point, means how much the distance of load having the eccentricity, how much having the eccentricity of the total load. That is what we have calculated. So in the total 5 kilonewton, 5 meter distance, we have reached up to 4.151 and remain distance is this one. So this distance is calculated as 0.485. 0.485, right? And this distance is the eccentric value for this 200. Because if you consider why it is not considered for 180 is because if you consider the 4.5 and since for 180 it is, if you consider it is nearer to, so 4.515 minus 3, so how much we will be getting? It will be 1.515, right? So if you consider these two values, 1.515 will be the larger value compared to this value. So on this basis it is considered which is nearer to 200 kilonewton. Right? And the eccentric distance of 0.485, which is from 200 kilonewton load, that has to be considered in the calculation for here. Again it is shown in the question. 0.485 is the total distance and distance of the CG, and its position is already considered from the support A. Same thing what we have considered in the previous problem. So total span is 12 meter. From the end we are considering, or else in the previous problem what we have written, L by 2, which is nothing but 12 again. L by 2 minus the distance by 2. Distance by 2 is why we are considering is because the distance is considered up to here is 0.485, and again that distance need to be divided equally on the either span, on the right hand span and on the left hand span, right? So for this for equal distribution we have to consider it for a half, and that half need to be coincide with the that is with the total length. So that is considered, and that has to be considered on the right side, and remaining will be on the left side. Say I would like to write over here like this. So how this would be, here it is a total of 4.485. Before that it is total of 4.515 and plus half of this one 0.485, that is plus 0.24, 0.242, point, it is 4.8, that is 4.515 plus 0.242. That is 4.757. That is the total distance that is from here to here. If you consider the point, that means here if you have, that is the total of 4.757, and in the remaining distance how much it will be, and remained of the total 10 meter, total 10 meter, if you deduct that 4.757, it will be 5.243. that is the distance, and remaining distance that has to be known, and that means up to here. That is calculated in this manner. So for that, so in the 12 meter distance, in the 12 meter span, the total of half of the total 12 meter, in this half total 12 meter, the 0.485 is considered as a section for this, and remaining distance is having the 11.757, and that is the total distance of 11.757. In the total 12 meter, if you deduct 11.757, and it will be remained with 12.243. And 12.243 is the total distance on the right hand side, and it is on the left hand side. So with these two loads, we need to have the coefficient values for each section. So for y1, if you want to calculate, so what is the distance from here? Here it is 5 meter distance, that is 5.243, and remaining distance will be calculated in this manner. So here it is 11.757. Here it is total 11.757. For the section of y1, it is to be deducted 5 meters. It is 3, and here it is 2. At this point, at this section, that means this section is coincided with the CG of the load itself, minus five, that is 11.5, that is 757, 11.757 minus, that is the 5. So then you will be getting the coefficient value for this y1, that is 6.757, to get for the span of 11.757. That means here in this calculation we have calculated the distance from the support, from this distance from this support, and for y2 that is 6.757 plus 2, and this is the span we are adding to. The plus 2 will be the 8.757. that is, again it is written in this here. And for y3, if you consider, since it is from the right side of the section, so in the total span of 12, it is of 2 meter, that is 12.243. In the total span of 12.243, it is 2 meter, and remaining will be 10.243, that is written for the total span of 12.243. And next for y4, on the right side we need to consider from the support. So it is 12.243 minus 2 and 3. So minus of 2 plus 3, that is 5. 5 minus 12.243 minus 5 will be 7.243, and dividing with the total distance. And that will be considering the coefficient values for the sections. Again for YC, we need to have the Z into L minus Z divided by L. And this is the most usual formula that we have considered for calculation of YC. So here, that is YC, we have calculated for 5.99, which is nearer to 6. So absolute maximum bending moment that need to be multiplied with the notations of that is intensity of load, ET, into the coefficient value for y1. y1 is 6.757 divided by 11.757. That is here written plus 80 into the intensity of this load, sorry, coefficient value of this load, and then 200 into, that is again it is unit load because 12 by 2.43, and that is 12.243 divided by 12.243, which is unit. So in this case we have not multiplied. At the end the YC has to be multiplied for all loads. For all loads at the end the YC has to be multiplied over here. So once you do that, you will be end up with the total maximum absolute bending moment. So this is what they have asked in the question to calculate for the bending moment for the given train of loads. Right, this is this much. If you write it, and you'll be able to get the half of, and that is total marks for the total and allotted for the marks. Okay, this is all about the problem what we have considered in this class. Regarding this problem, if you have any doubts, please let me know. And apart from that, in previous class we have already given one assignment question on this, on the previous problem. I hope how many of you have solved? So how many of you have solved? Yes, Abhishek.
Sir, that shear force calculation 0.5L.
This one?
Yes, sir.
How it is got 0.5?
That no, sir.
Not sir. Negative sign ತಗೊಳ್ಳಿಲ್ಲ ಸರ್ ಅಲ್ಲ
ಇಲ್ಲಿ
ಅಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ತೊಗೊಂಡು ಸರ್ ಇವು ಯಾಕೆ ನೆಗೆಟಿವ್ ಸೈನ್ ತಗೊಂಡಿಲ್ಲ ಅಂತ.
See, if you consider the negative sign, it will be in the negative only. See, for example, 180 into 0.75. What you get, we'll just write it here by calculation. 180 into 0.75 will be 135. Right? And here it will be negative, you are saying, right? So 200 into 0.58 will be 116. And here it is 80 into 0.33, 26.4. And here it is